Hey everyone, ready for another deep dive? Today, we're wading into the world of large language models, or LLMs for short.
Yeah, these things are pretty wild.
They really are. We're talking about AI that can code, translate languages, even get creative with writing different kinds of content.
And the field is exploding right now. New models popping up all the time.
Exactly. And today, we're focusing on one that's really caught our eye, YuLan Mini.
Interesting choice.
It is, right. Developed by a university lab, and what's really remarkable is how data efficient it is.
Data efficient meaning.
Meaning it can achieve impressive performance with way less data than these giant models we usually hear about.
So kind of punching above its weight class.
Exactly. So in this deep dive, we'll be dissecting YuLan Mini, looking at its architecture, the tricks they use to make it so data efficient, and how it stacks up against the big players in terms of performance.
Sounds like a plan.
So first things first. This YuLan Mini, it's tiny compared to, say, a GPT-3 or something, right?
Oh yeah, we're talking about a model with just 2.42 billion parameters.
Which, for our listeners who aren't knee-deep in AI specs,
That's small. Like really small, especially when you consider the industry giants are sporting tens of billions of parameters.
right. So how does something so small manage to compete?
Well, that's where the data efficiency comes in. They achieved comparable performance to much larger models. But get this, they trained it on just 1.08 trillion tokens.
Okay, gotta admit, I'm not totally up on my tokens. Help me out here.
Sure, think of tokens like the individual pieces of words that the model processes. So 1.08 trillion, that's a lot. But other LLMs are trained on data sets many times larger.
So they're doing more with less. I'm intrigued. What's their secret?
Well, it's a multi-pronged approach.
Hmm.
They've got a really sophisticated data pipeline. Think of it like this. They didn't just grab any data they could find. They were really picky about what they used.
Like super selective.
Exactly. It's a three-stage process. They have a warm-up phase, then stable training, and finally this annealing stage. Each stage uses data in a different way.
Okay, break that down for me. What's going on in each stage?
So in the warm-up, they're basically getting the model ready for the heavy lifting. They use a smaller data set, carefully curated. Then stable training, that's where they throw the bulk of the data at it, let it really learn.
And the annealing stage, what's special about that?
That's where the magic happens. They fine-tune it, really optimize its performance. But we'll get into the nitty-gritty of that later.
Gotcha. So back to the data itself. You said they were picky. What were they looking for?
They really focused on three key areas: math, code, and reasoning. They wanted YuLan Mini to excel in those domains.
Interesting. So not just general knowledge, but really honing in on specific skills.
Precisely. And they weren't just grabbing random math problems or code snippets. They used some really clever techniques to find the best possible data.
Like what?
Well, for one, they used something called topic-based text recall. It's a way of digging through massive data sets to find those hidden gems that are really relevant to what they're trying to teach the model.
So not just quantity, but quality of data. Makes sense. But I'm guessing it wasn't all smooth sailing. Didn't they have to worry about things like data contamination?
Oh, absolutely. That's a huge concern in LLM training. You don't want your training data overlapping with the benchmarks you'll use to test the model. It's like giving a student the answers to the test beforehand.
Right. Totally skews the results. So how'd they avoid that?
They were meticulous about cleaning their data. They even used n-gram analysis to spot and remove any segments that might have crept in from the benchmarks.
N-gram analysis, huh? That sounds pretty technical.
It is, but basically it's a way of analyzing sequences of words to see if there are any matches with other data sets. Helps ensure everything's original and unbiased.
Smart. So they've got the data down, it's clean, it's focused. What's next? The actual training, right? But don't LLMs have a reputation for being, well, a bit temperamental during training?
Oh yeah, they can be. Instability during training is a big headache. It can waste a ton of time and resources. And with a smaller model like YuLan Mini, they really couldn't afford any hiccups.
So how'd they tackle that? Did they find a way to, like, keep the model from throwing a tantrum mid-training?
Sort of. They figured out how to monitor the model's internal state as it learns, looking for signs of trouble.
Internal state. You're going to have to elaborate on that one.
Sure. So inside these LLMs, there are these things called hidden states. They're basically snapshots of the model's understanding as it processes information.
Okay, so by watching these hidden states, they could tell if the model was about to go off the rails.
Exactly. They discovered that when these hidden states started to explode, it was a warning sign that instability was just around the corner.
Like a canary in a coal mine, but for AI training.
I like that analogy. And armed with this early warning system, they were able to implement some really clever techniques to stabilize the training process.
Fascinating. So they've got the data, they've figured out how to keep the training on track. What's next in the YuLan mini saga?
Well, that's where the annealing stage comes in, and this is where things get really interesting. But we'll save that for after the break.
All right, cliffhanger. Everyone, grab a drink, stretch your legs, and we'll be right back to uncover the secrets of the annealing stage and reveal just how powerful this tiny titan really is. Stay tuned.
All right, so we've covered the data side of things. But how does YuLan Mini actually work? What's under the hood?
Yeah, spill the technical beans.
Well, they went with a pretty classic architecture for LLMs, a decoder-only transformer. But they made some tweaks to make it super efficient.
Like what?
Well, they made it tall and narrow, meaning lots of layers. But each layer is relatively small.
Huh, interesting. Why that approach?
It's all about balancing computational cost with performance. Lots of layers allow for more complex processing, but keeping those layers slim helps keep things manageable with their limited resources.
Ah, makes sense. So it's like a skyscraper, right?
Yeah.
Many floors, but each floor is smaller.
Exactly. That's a great way to put it. And on top of that, they employed some other clever tricks to squeeze even more efficiency out of the model.
Okay, I'm all ears. What kind of tricks?
Well, for one, they tied the model's embeddings.
Embeddings. Remind me what those are again.
Right, so embeddings are basically how the model represents words and concepts as vectors, those strings of numbers.
Right, right. The math behind the words.
Exactly. And by tying these embeddings, it means the model uses the same set of vectors for both understanding and generating text.
Huh, I see. So less redundancy, more efficiency.
Exactly. And it seems like this also had a positive effect on training stability. But one of the most interesting aspects of YuLan Mini has to be their focus on data quality.
Yeah, we talked about that a bit earlier. Really selective about their ingredients.
Exactly. They weren't content with just using off-the-shelf data sets. They actually went out and created some of their own data.
Wow, so they weren't just data curators, they were data creators too.
Exactly. They wanted to make sure YuLan Mini had the right kind of data to learn those specific skills they were after, especially reasoning.
Right, math, code, that kind of stuff. But how do you even create data for something like reasoning? Seems pretty abstract.
Well, they focused on a technique called chain of thought reasoning. Basically, they generate text that demonstrates the step-by-step thought process involved in solving a problem.
So instead of just giving the model the answer, they're showing it how to get there, the logic behind it.
Precisely. It's like teaching the model to think like a mathematician or a programmer, breaking down complex tasks into smaller, more manageable steps.
Really cool. And I imagine all this extra effort on the data side really paid off during training, right?
It seems so. It's like they gave YuLan Mini a solid foundation to build upon. They even used those hidden states we talked about earlier, not just for spotting instability, but also to guide their choices during each stage of the training process.
Right, the warm-up, stable training, and annealing. Can you remind us what happens in each of those stages?
Sure. The warm-up phase is kind of like easing into a workout. They start with a smaller data set, a lower learning rate, so the model learns gradually.
Okay, and then in stable training.
That's where they unleash the bulk of the data. Really let the model sink its teeth into it and build up its knowledge base.
Sounds intense. And finally, annealing. This is where the magic happens, right?
Exactly. It's like the final polish, where they fine-tune the model for peak performance. They slowly reduce the learning rate again, allowing for more precise adjustments, and they also extend the context window.
Context window meaning?
It's basically how much information the model can consider at once before generating a response. By extending it, they're enabling YuLan Mini to handle more complex tasks that require holding a lot of information in mind.
Makes sense. So they're pushing the model to its limits, making sure it can tackle those really challenging problems. But the real question is, how well does it actually perform? Can this little model keep up with the big boys?
That's the million-dollar question, and the answer might just surprise you. Let's dive into the results and see what YuLan Mini can really do.
All right, let's do it. I'm eager to hear how all this meticulous preparation and training actually translates into performance. Hit me with the results. Okay, time for the moment of truth. How does this tiny titan actually perform? They put YuLan Mini through the ringer, benchmarking it on all sorts of tasks. Let's start with the brainy stuff. Math. How'd it do?
Oh, they didn't go easy on it. They tested it on some really tough math problem sets, like Math 500 and GSM 8K. And get this, it actually outperformed some much larger models.
Wait, hold on. You're saying this model, with just a fraction of the parameters, beat out the heavyweights. How?
It's a testament to their approach to data, I think. Remember how they were super picky about the math data they used? And they even generated their own examples, focusing on that step-by-step reasoning process.
Right, right. Teaching the model to think like a mathematician. So it's not just about brute force, it's about quality data and smart training techniques.
Exactly. And it's not just math. YuLan Mini also showed impressive skills in code generation.
Oh, yeah, that's right. They tested it on, what was it, human eval and MBPP?
Yeah, those are the ones. These benchmarks evaluate how well a model can translate instructions into working code, and YuLan Mini scored really high, suggesting it could be a pretty powerful tool for developers.
It's wild to think you could describe what you want your code to do, and the AI just writes it for you.
It could really change the game for software development, potentially free up developers to focus on more complex, creative tasks.
Okay, so it's a math whiz, a coding guru,
Yeah.
but is it a one-trick pony? How did it do on those more general language tasks, like reading comprehension, question answering, things like that?
It held its own. They ran it through a whole battery of tests, looking at things like language understanding, common sense reasoning, even logical deduction. And across the board, YuLan Mini showed strong performance.
Impressive. So we're talking about a versatile, well-rounded model, all in a compact package. But if I recall, there was one area where it faced some limitations, right? Something about long context understanding.
Yeah, that's right. While YuLan Mini can handle a decent amount of context, it's not quite at the level of some of those models specifically designed for processing massive amounts of text.
Makes sense. It's a trade-off, right? Smaller model, less computationally intensive, but maybe some limitations in certain areas.
Exactly. Plus, they were working with limited resources, and training on those really long sequences requires a ton of computational power.
Right, right. So overall, what's the big takeaway here? What makes Yulan Mini so noteworthy?
I think it really challenges the assumption that you need mountains of data and a supercomputer to create a powerful LLM. YuLan Mini proves that with careful planning, smart data choices, and innovative training methods, you can achieve remarkable results even with a smaller model.
It's all about working smarter, not harder.
Yeah,
Efficiency and ingenuity winning the day.
exactly. And it really makes you wonder, if a university lab can achieve this with limited resources, what's possible as researchers continue to push the boundaries of data efficiency in LLM development?
It's an exciting thought. Could we see a future where these powerful AI models become more accessible to everyone, not just big tech companies, but researchers, developers, even everyday users?
The possibilities are endless. YuLan Mini gives us a glimpse of what might be possible, and that's a pretty inspiring thought.
Absolutely. Well, there you have it, folks. Our deep dive into YuLan Mini, a tiny titan making big waves in the world of AI. We've explored its clever design, its data-driven approach, and its impressive performance. And we're left with a sense of wonder at what the future holds for this rapidly evolving field. Thanks for joining us.